Howdy, I'm Pragati Arumugamudaya, and I'll discuss Milestone 3 for the course Advanced Data Management. Today's discussion will be based on replication since the use case of Ethermart briefly described a situation where a database hiccup happened and that caused losses on the e-commerce platform. So I'll discuss various replication strategy and I'll first explain what standard replication is. In MariaDB, standard replication is an asynchronous master-slave setup where the primary servers logs all the changes first and then the changes are replicated in the secondary server later. So this is an asynchronous operation, which means the data replication doesn't happen instantly. First, the primary commits, and then the committed transaction is replicated in secondary. And also, it follows shared nothing principle. This means the every server in the every node in the cluster has its own storage, memory, and CPU, and none of the resources shared between any of the nodes in the cluster. And according to the CAP theorem, this standard replication is an AP system, which means availability and partition tolerance is preferred more than the consistency because we are first committing the data and then only replicating, which will cause some consistency issues. And if you see the flowchart below, this is the execution steps of the standard replication. So first, the primary node receives a transaction, for example, an update, and then the primary node writes this transaction into its binary log. Now, an IO thread that is constantly running in the secondary node will get triggered once an event is registered in the binary log. And now the IO thread will replicate all the contents of the binary log into a relay log file, which is stored in the secondary node. Now, the SQL thread that is running in the secondary node will execute this relay log and applies all the contents, replicates all the data into the secondary nodes. And standard replication uses a mixed bin log format, which means the bin log can be row based or statement based. And to discuss the advantages of replication, standard replication, it ensures increased read scalability and high availability, which means there are multiple nodes with the redundant content of data. So even if one node fails, the customer can connect to any of the other nodes in the cluster. So the read scalability and high availability is always ensured. And there is no single point of failure, which means even if a single node in the cluster fails, there are multiple other nodes which will ensure that the cluster as a whole is not failing. And this is only applicable for read scenarios. For the write scenario, if the primary node fails, then the write is temporarily halted, thus eliminating no single point of failure case. And in this case, we have to either wait till the primary is up or else there is a manual interruption is needed to promote one of the secondary server into primary server. This is only applicable for read. And other advantages are flexible replication options and increased cost effectiveness. And few of the disadvantages are this causes replication lag, which means the primary, as discussed before, the primary first commits the data and then only the secondary clones it from the primary. So there is a time difference between the data consistency happening in all of the nodes. Thus, this is called replication lag, and we are sacrificing consistency. And in case of any failure, manual interruption is needed to resolve it. And since the same data is stored across multiple secondary nodes, data redundancy is also a disadvantage. And I have implemented this standard replication for our Ethermart use case. And I feel this standard replication is more suitable for the tables such as reviews and products, because reviews and products are the tables where we can actually compromise consistency for availability. Because whenever the customer opens the application, they should be able to see some product catalog at least. Here we are preferring availability more, and also reviews the same. Even if the reviews are not consistent, there should be some reviews for the product to enhance the interactability. And I performed the standard replication in my existing Ethermart database, which I used in Milestone 1 and 2. And thus, I had to do a manual backup of all the existing data and then clone it back again in the secondary databases. This didn't happen automatically when I created the standard replication setup. And also, one thing that I noticed is even if the secondary nodes are in read-only mode, the root user is able to perform write operations in the secondary server. But this write operation that is performed in the secondary server is not replicated, not cloned back into the primary server. So even though we are performing write, it is not getting cloned in the primary, ensuring the consistency of standard replication protocol. Now we'll see the execution. So as I mentioned before, I have already implemented the standard replication setup, and this is the security group that I created for this standard replication setup, where I have created a MySQL type and TCP protocol security config with port ranges 3306, and I have tagged this in all of my three primary as well as two secondary instances. So this is my Ethermart primary instance, and over here I will open my.cnf file, and you can see that I have configured that MySQLD configurations here, giving server ID as 1, and then a log base name as master1, as well as I'm ensuring sync bin log, which means whenever an event is triggered here, it will automatically get replicated in the secondary servers also. So this is my my CNF configuration for primary cluster. And for my secondary clusters also, I will go inside my MIU.cnf file, and you can see I have implemented server ID is equal to 2. So I'm giving a unique server ID. Also, I have given read only is equal to 1, ensuring this secondary cluster will only be in read only mode and no write operation will be happening here. So now what I'll do is I will go into my MariaDB cluster, MariaDB terminal, and then I will show the existing databases. So you can see Ethermart database is already existent because I have implemented this and already in the database that used for milestone 1 and 2. And now I will use Ethermart to perform few read operations. So I will select my customers table. And if you see here, I already have 118 rows of data in my customers table. And if I do the same in my secondary cluster, then I should see the same results. So I will use a format, and then I will select the contents of my customers table. So you can see here also there is 118 data. Now what I will do is I will try to perform a write operation, insert operation in my primary server, so that this write operation should be reflected among the clusters. So I have already inserted the row, and now if I do a select, I can able to see a new row inserted, 119 row inserted in my primary database. And if I go to my secondary cluster, which is Ethermart replica, and give a read select query, now you should see, yeah, this 119 is also inserted in my secondary database. Now I will do the operation in the reverse order. I will try to insert a new row in my replica in the secondary node. And yeah, so now you can see the insert has been happened successfully because I have logged in as the root user. But what you'll notice is even though the insert is successful here, if I execute the select command in my primary database, it is still 119. The newly inserted row in secondary is not reflected in primary, thus ensuring the integrity of the whole standard replication process, which is cloned from primary to secondary and not vice versa. Now we'll move ahead with the presentation. So the next topic is Galera clustering. So in MariaDB, Galera clustering is a synchronous multi-master replication setup where all nodes stay consistent by replicating data in real time. So in Galera clustering, all the nodes in the cluster is a primary node. So it is not a master-slave approach. Instead, everything is a primary. Thus, write operation and read operation is happening in all the nodes, and it is following a peer-to-peer clustering architecture. And Galera clustering is based on certification-based replication protocol. So what this means is, I'll explain the flow chart to explain it more. So the operation of Galera clustering is one of the node in the cluster will receive a commit or transaction. For example, node A. Now node A packages this transaction and broadcasts this transaction to all other nodes. For example, node B and C. And now the other nodes, which is B and C, will perform a certification check and ensure if this write operation is not getting any conflicts in the database. And if there is no other conflicts, then these other nodes will send OK to node A. So node B and node C will send OK to node A. And now if node A receives OK from the majority of the nodes in the cluster, then this commits the transaction locally and then reports success to the application. So by receiving majority OKs from all the other nodes, and then only we are committing the data. So this is called certification-based replication protocol. And this method is called virtually synchronous principle because we are not committing the data in the database unless and until all the other nodes are also replicating the same data. And by this, according to the CAP theorem, this Galera clustering is a CP system. Here we are giving priority to consistency more than availability because the data is committed only if all the other nodes are also acknowledging the same. So we are sacrificing availability here. And Galera clustering is strictly row-based bin log format. And also split brain is a common scenario in Galera clustering. So what split brain is, it is a situation in a cluster where two or more nodes lose communication with each other and each node assumes it is the primary, leading to conflicts. And quorum is basically the minimum number of nodes that must agree and be connected for a cluster to function properly. So this helps prevent the split brain scenario. And essentially, it is a good practice to have an odd number of nodes in a Galera cluster. And thus we can ensure there is a no tie scenario happening in quorum. And thus we can always recover a split brain scenario. So to discuss the advantages of Galera clustering, Galera is a multi-primary capability structure. Thus, even if one node fails, all the other nodes can ensure both read and write operation. Thus, the Galera cluster is seamlessly fault tolerant. And it also ensures zero data loss. We are committing a data only if all the other nodes are acknowledging that there is no issues with it. So we can ensure that there is zero data loss while committing, and also automatic node provisioning. So while addition or deletion of a node or while performing any fault tolerant operation, there is no manual interruption needed except for permanent deletion of a node, in which case there is a slight manual interruption needed. Apart from that, everything is automatic node provisioning. And there is no failover delay. Even if one node fails, it is automatically configured. The request will be rerouted to the another node, and thus there is no failover delay. And the disadvantages are it will cause high latency. Since the cluster is waiting for the acknowledgement from all other nodes while commit, the certification method will cause high latency. And also there may be possible write conflicts while there are simultaneous writes happening in the same node or different nodes. And also it is highly network dependent since if there is any partition tolerance, split brain scenario can happen, causing issues with the Galera clustering. Now, cluster operations in Ethernet. So I have performed Galera clustering using 3 nodes, and I think this is more suitable for customers and orders table, where the consistency of the data is really, really important because customers is essentially the identification details of the customer, as well as the orders contain the list of this basically the card details, and card details deals with price, and thus it has to be more consistent than available. And while implementing this while implementing the Galera clustering in Ethermart, I encountered split brain scenario when I accidentally closed my browser, and since my AWS settings is basically configured to shut down if it is idle for a long time, all my clusters got shut down automatically, thus causing a split brain scenario for me. And I resolved the split brain scenario later by identifying which is the bootstrap server and then manually bringing up the bootstrap server first and then sequentially bringing up other servers. And also I performed addition and deletion of nodes and also did some failover testing, and I will go over through that one by one. So I have performed my Galera clustering already, and I will run this command in one of my Galera cluster. Okay, so if you see here, this is the security group that I have created for the Galera clustering. And you can see I have created a total of 5 security inbound rules here so that I will enable the MySQL port, TCP and UDP ports configured for the corresponding port ranges. That is essential for Galera communication between one node and another nodes. And I have also tagged the security group to all the 3 Galera nodes. And this is one of my Ethermat Galera node, and I will execute this command. This command in and I will execute this command in my Galera cluster 1. So you can see my cluster size is 3, which means my Galera cluster has 3 nodes connected to it. And now I will go through the configuration one by one. Sorry. And now I will open my galera.cnf file, and you can see I have configured, sorry, I have configured all my WS rep config here, giving my cluster name as Ethermart Galera cluster. And then you can see I have given all the IPs, which is the three existing nodes IPs for the Galera cluster to automatically get connected whenever the server is restarted. And also binlock format is row, which is an essential part to note here. And then I'm setting the node specific configurations also. And similarly, I have done the same for the three different nodes. And now I will exit this. And this is how I'm setting up the Galera cluster. And now I will try to perform adding a new node into this Galera cluster. So I already have a fourth Ethermart Galera instance created using the EC2 instance script that Professor G gave us. So I will go ahead and I will connect to this node now. And then after connecting to this node, what I should perform is I should go into my Galera CNF file and okay, I will go into my Galera CNF file, so which is inside the etc, and I will open my galera.cnf. And now what I have to do is I already configured this. So basically, I have added this a cluster address, which is the existing three IP addresses that is already connected to the node. And this node specific information has Ethermart Galera 4. And over only in the node specific information, I am mentioning my IP address of the fourth node. I am not adding my fourth node's IP address in the cluster address. That is an important point to note here. If we don't do this way, then the node addition will get failed for sure. And now my config is ready, and I will exit from the config file. And the next step to be performed is I should restart my MariaDB server. So I will go ahead and restart my MariaDB server. So in the fourth Ethermart server, what I'm doing is I'm performing a MariaDB restart operation. So this will essentially restart my MariaDB. And since I have configured my Galera.cnf with the corresponding Galera cluster config, once it is restarted, it will get automatically connected to the Galera cluster. And now I can check the status of the Galera cluster by executing the rest cluster size command in any of the one of the four nodes. So I will go ahead and execute it in here. In here, and it will redirect me to enter the password for the security reason. And you can see the cluster has been added successfully, and now the size is 4. And also I will go into my MariaDB to show you guys how the data is also replicated. Now use show databases. Show databases, you can see the Ethermart data is available in the newly added node, which is the Galera 4th node. And I will also show one of my previous nodes, for example, Ethermart Galera 1 node. I will go into MariaDB in this node and then also show databases here. So yeah, you can see it is already there. And now what I'll do is I'll try to I will perform the same insertion operation in the customer table. Similarly, what we did for the Ethermart standard replication. So I'm using the Ethermart, and then what I'm doing is I'm going to insert this data into my customers table. So I'm going to perform an insert operation, which is successfully performed. And then if I query this, you can see 119th row is added, which is the new row. Now, if I go to my fourth cluster again, and if I give select from customers, sorry, I should first select the database. And then if I do the select operation, you can see the 119th row is also added in the fourth cluster. Thus, I have added a new node. Also, I am ensuring the data consistency across the databases. And now I'll proceed with deleting a node in Galera cluster. So to delete my node permanently, what I have to do is first we already saw that the cluster size is 4 right now. And then on what I'll do is I will perform MariaDB stop on the node which I want to delete. So for example, if I want to delete the fourth node, what I will do is I will perform a MariaDB stop operation. So now I have performed MariaDB stop, and also since I'm permanently deleting it, I'm disabling the Maria node as well, MariaDB node as well. So I'm going to disable MariaDB. And after this is done, what I'll do is I have to delete the IP configurations of this particular node in my remaining nodes. For example, this is my first cluster of the Ethernet Galera one, and now I will go inside nano galera CNF config. And if you see here, I have the rest cluster address and I have 3 IP addresses tagged into it. So in this case, since I'm deleting a newly added node, the address of the fourth node is not available in this cluster, in this cluster address value. But then if it is one of these 3 things, then I should be deleting the IP address of the corresponding node that I'm deleting. And then I have to save and exit the file. And after doing that, I have to ensure if it is deleted properly. Since I have already deleted it, and then now what I should do is I can check the size of the Galera cluster again. And then you should see the Galera cluster size should be 3 now, not 4. Um, I think. Okay, I have to enter the password again. And yeah, you can see the Galera cluster size is 3 and not 4, which means I have removed the fourth cluster from the Galera DB. And now I will, after deleting, what I'll do is I will also perform another insert operation to verify if it is deleted properly. So I'm doing ethermart, and then I am performing the same insert operation again. So I will perform this insert operation, and I will update the ID to not cause any issues. And if you see here, I'm inserting it successfully, and I'm able to view it in my Ethermart Galera cluster 1. But if I go back to my Ethermart Galera cluster 2, I will not even be able to connect to my MariaDB because I have manually stopped it in the first place. So by this, I am deleting the node successfully. And yeah, and this is deleting. And then I will also perform fault tolerance testing here. So in order to perform fault tolerance testing, what I'll do is, now we already checked my Galera cluster size is 3. Now what I'll do is I'll create a new database called heartbeat, so that this database table will get inserted in a while loop throughout, like consecutively. So I'll go ahead and then in one of my cluster, for example, in Ethermart Galera cluster 3, what I'll do is I'll create a nano and heartbeat.sql file. I'll create this one. And then you can see I have pasted the SQL code to create a database, heartbeat test, and then this also has a heartbeat table. Now I will execute this. Now what I will do is I will write a code snippet that will constantly insert data into this table unless and until I manually interrupt it. So I am going to perform a write operation into this heartbeat table, and this is going to happen infinitely until I stop it. So you can see the data is getting inserted here, and I'm not going to stop it. So if I go over to any of my other Galera 2 or Galera 1 database, I can stop any of the Galera database. For example, I will stop this one. So this is my okay, before stopping, what I'll do is I'll go to MariaDB and then I'll read MariaDB and I'll read use. And then I'm going to perform a select query from the heartbeat table. So if you see here, I'm performing a select query from the heartbeat table. And you can see there is 408 rows that is already existing. And now what I'll do is I'll go ahead and I will manually stop this MariaDB execution. Now the MariaDB execution has been stopped, but still the write operation here is still going on. And now what I should see is I will go to any other cluster and I'll check the status of the insert operation. So I will use, and then I will select. So you can see the data has been inserted again and again, and the data index is 540 now. So what I'll do is I will stop this execution, and now I will check what is the latest entry. So I will check what is the latest entry, which is 564. Now this 564 entry is available in Galera 1, which is an executing node. Now Galera 2 has been disconnected from all this cluster. And now the recent entry was 408. So when I bring this cluster back, what should happen is I should see the latest content. So I will start the cluster again, start the MariaDB again. It will take some time to reboot. And once that is done, I will go inside my MariaDB and then I will check the status of my heartbeat. And you can see the latest data, which is 564th data, has been replicated, ensuring even if one node is failing temporarily, when the node is brought back up, the replication is up to date. And thus, whenever the user is connected to any of the node, the user will be able to see the latest data. And by this, I have also performed fault tolerance. And now coming back to the presentation, vector capabilities. So vector capabilities is also one of the most important concepts of the MariaDB, which will enhance and help us in the AI development. So vector capabilities supports native vector data type for storing embeddings. So all the user queries are converted into vector data type, which is embeddings, which is words is converted into numeric format, and this will enable similarity search using cosine functions and Euclidean distance function. And we can integrate this vector search with the standard SQL and relational data. And then this vector search embeddings is passed as an input to the LLM model. And thus we can do searches like, instead of the searches in which we use like-based, reject-based patterns, we can actually retrieve data using the context and the meaning of whatever we are searching. And vector capabilities use HNSW indexing for fast and approximate nearest neighbor search. And it is ideal for use cases which is using AI and semantic search recommendations and RAG applications. AI disclosure. For this, I have utilized ChatGPT and Gemini mostly, and I use these AI tools to primarily leverage to debug errors while performing all these replication operations. And I also use to double check the security group configurations, which I did before. And also, AI assisted me in generating the flow charts for the PPT. The one limitation in AI outputs is AI output depends heavily on the prompt that we give. If we miss any contents, example, if we miss that we are performing standard replication, it may probably give us the result for Galera replication. So if we miss any details, then the usability of the code that it provides reduces. And reflection is AI is best used when we leverage our understanding. We use our solid understanding of the principle and leverage AI to build on top of it. So we can get the best output only if we do like that. So thank you. This is my presentation.